What is up, guys? Mr. B here, bringing you another sweet, wicked, awesome math video on this beautiful Sunday. This video is going to be about absolute value functions and transformations. So what I'm going to do is I'm going to transform a absolute value function using transformational form and show you how we do that. The biggest thing to remember is when you have an actual function is that an actual function has an actual base table. It's not just some random thing I'm pulling from my head or your teacher's pulling from their head, or like, you know, those random line things that you get with the different points on them. It's an actual function that has a base table that's a set known number of values that you need to know or you need to be able to generate to be able to do these particular questions. But they're really no different from just a general transformational function. If you guys have any questions about anything, please drop it in the comments. I'm looking to have some more engagement in my channel. As always, if you like this video, please like, share, subscribe, and bam, into the screen. All right. So, no, guys, I don't know about this one. We'll see. All right. So we've got a transformational form, and it says the image of y is equal to the absolute value of x. So somewhere along the way, hopefully there was a nice, polite math teacher who taught you what an absolute value function is. And basically it's just you make the y values positive, all right? So that's the simplest way of thinking it. If you put x in here, if you put a negative x in, it makes those values positive. So all the y values that would have been negative now become positive, essentially, right? So we'll talk about in a second how to generate that table. But first, let's ignore that and let's focus on what we know about transformations. We know lots about transformations. We know how to find a, b, h, and k. We know what transformational forms should look like. And we also know that we need to be rocking some double brackets. And if we are not, bam, we got to get some double brackets times 2, right? So transformational form, I always tell my students, you know, when in doubt, write it down and compare. Do they look the same? If the answer is yes, we will rock. If not, then we must stop, all right? And this is pretty much it. We don't have the double brackets, all right? So if you look at this thing, that the 1/2 is right next to the x. What should be right next to the x? This little bracket is like the b and the x. They hate each other. They need to be separated with a bracket. So if you don't have that bracket, you need to put it there. Everything else after that will be messed up. Certainly, there will be a lot of good stuff there, but you'll lose some marks because you'll have, you'll have your h value wrong. So let's rewrite this thing with the double brackets. We got our negative on the outside, f, and then 1/2. And it doesn't matter what you get when you factor out that b value. If it looks god-awful, you need to go with god-awful. Most times teachers create them so they work out good, but it's not really factoring where we can factor it if we possibly can. It's we factor out anyway, all right? So we take the 1/2 outside, and remember, dividing by a fraction like 1/2 is the same as multiplying by 2. So if I divide that 1 by 1/2, it gives me 2, all right? So 1/2 divided by 1 divided by 1/2 is actually 2. And then plus 3. Again, guys, this is not a video on, you know, dividing fractions. If you need that, certainly look on my channel or just Google dividing fractions and you'll find something, I'm sure. All right. Not to insult you or anything, but like, you know, this is something, and it's, I said that wrong. That's my bad. If you have trouble with it, come see me and I will walk you through it if you are one of my students. If you are not one of my students and you have trouble with it and you want some help, comments and I will help you out. All right. So now that we have that transformational form, I don't like to be frank like that, guys. That's not me. So my apologies. All right. We write our a value. So where the a is, there's a negative. So that means -1. My b value, exactly what it is. My h value. So if you're not familiar with transformations, that this already has a minus in here. So we just kind of have to think about like x minus, what did I put in here to keep that minus? Well, it must have been positive 2. What I tell my students is if there's a negative, then we take the opposite sign. So if there's a negative, we take a plus h. If there was a positive here, we take a negative h. And then k, hanging out here all alone, it's 3. And I always do that. I forget to write plus k. You're probably cursing at the screen. There it is, plus k. So I usually it sinks into my head what k is, and I write it there. So k is always whatever k is, because it's positive. The only ones you need to worry about is the ones that have the minus in front, and that's only h. So now that we have that, we have to write our mapping rule. So we do xy goes to 1 over b x plus h a y plus k. So if you're wondering where that mapping rule comes from, it's not a video explaining that. Basically, it's just a known rule. In your class, hopefully your teacher took you through the development of that rule and how it works and how stretches and reflections and translations affect points. But at the end of the day, in order to do that, you don't need to know really any of that stuff. You just need to know what the mapping rule is and how to run it. So I would highly recommend knowing everything there is to know about stretches, reflections, and translations. But for this, it's kind of an autopilot type of question. And all we need to do is plug the values in. That's it. So where I see a A, a B, a H, and a K, I'll plug them all in. So only thing you need to remember is that B is reciprocated. So it's 1 over B. So if my B value is 1/2, then I reciprocate it to the mapping rule to get 2x, and then plus 2. Then A, so A is negative y, and then plus 3. You could put negative 1 there if you wanted to, but you don't need it, okay? Certainly, if it helps you, by all means, do it. Now we're to the point where we need to decide, like, what are we going to actually transform? We don't have a table here. All we're given is this y is equal to the absolute value of x. That is what we call a base function, all right? It is the simplest absolute value function that you can actually get. So we need to generate a table from that. We get to choose our values of x. And when we're choosing the base function, we really want to have it symmetric. So if you're familiar with absolute values, and hopefully you are if you're being asked to transform them, they look like V's. And they have kind of a vertex, a corner point essentially, a pointy little point where the bottom of the V will be, and that is at 0, 0. So we want to have a couple points on the side of that. So normally what I would do is I would go -2, -1, 0, 1, 2. 5 points is a lovely number to transform. Now, all the absolute value function does, and this is y is equal to the absolute value of x, all it does is make these numbers positive. That's all it does. So when I put it in here for -2, it makes my y value that I would get to be negative positive. And it makes this positive, 0 stays 0, and 1 and 2, they stay positive. So all the values that would have been negative y are now positive. They reflect back, all right? And again, this is not a lesson in absolute values, just more or less how to transform one. Then we're going to use the mapping rule to go ahead and transform those points. And with the mapping rule, all you do is you take your x values and you run them through the x part of the mapping rule, take your y values and run them through the y part of the mapping rule. So -2 times 2 is -4, plus 2 is -2. -2 times 1 is -2, plus 2 is 0. And the best thing about having our x values, just basically bump up by 1, we'll find a pattern over here. The pattern is going to be going up by 2, but I'm going to verify that just to make sure. And then 2 times 0, 0, plus 2 is 2. 1 times 1, 1 times 2 is 2, plus 2 is 4. And then the next one will be 6. 2 times 2 is 4, plus 2 is 6. With the y values, because we got 2, 1, 0, 1, 2, they should repeat, all right? So -2, right, because the negative is already there, so you put the +2 and it becomes negative. -2 plus 3 is 1. And then -1 plus 3 is 2. Then 0 plus 3 is 3. And then I should repeat. So we got the 1 again. 1, -1 plus 3 is 2. And then -2 plus 3 is 1. So we repeat it. So once we have that table, that's my transformed function. All right? So that's going to be this guy, right? The one that we were initially given. So all we need to do now is put that on the grid, and we should get a V shape, all right? So -2 and 1, right here. I'll move my ugly mug away. And then 0 and 2. Now, it's a possibility it could be upside down if it was reflected, which it was reflected in the x-axis. So that generally means upside down. and then 2, 3, right there. Now we should float back the other way. So we go, where's 2? So 4, 2, right there. And points should be symmetrical. So once you have these couple, the other ones kind of follow, right? And then 6 and 1. I still like to be precise, though, and actually really take my time and do it. So now we got our V shape. So what we're going to do is use our ruler. I was kind of lazy in the first bunch of videos I made, so I didn't really use a ruler, but here I'm turning over a new leaf. So there's my points connected. Notice I'm extending beyond those 3 points that I have. This is not a typical transformation where you got a set domain or range or whatever. With this, your domain is all real numbers because we have a particular function, right? So x can really be anything. It doesn't have to be a a set domain and range between this and this. It is all real numbers because domain of y is equal to the absolute value of x. You could have any value of x that will satisfy that and will work perfectly fine. So this is our transform function. Y is equal to negative f. And then I'm going to use my version with the double brackets, 1 over 2, x minus 2 plus 3. And there it is. That's how we transform an absolute value function. Now, one thing I'll say that you might come across is that not always are you going to have that f there. Sometimes that f might be replaced with the actual function. So instead of having that f, you might actually have this. So 1/2 x minus 1 plus 3. So that means the exact same thing as this. This is a general function, and then they told us to transform it using the absolute value of x. But they might just say, graph this, right? And, well, how do you do that? Well, we can do it with a transformation. So be aware you don't necessarily always have that x given. You might just have the absolute value transformational form given, in which case you rely on your know-how to be able to do that with transformational form. All right, everyone, this video is done. Thanks for watching. I really appreciate all the love that I get. If this video helped you, as always, like, share, subscribe, and I will see you guys in class. Peace.
A lot of boring math later.
I like this guy's mathematicals.